I am Anil Kumar. Welcome to my playlist with thousands of videos, absolutely free for last 15 years. In this video, we are going to see all the steps involved in graphing trigonometric function reciprocal transform trigonometric function which is given to us as f of x equals to minus 4 over 3 cosecant half x plus 2 pi by 3 plus 7 over 3. It involves a lot of fractions and many things to do before we start graphing of this cosecant function. Now in my playlist you'll find my method which is two-step method which I really promote and I love. You can also follow that method. So in this solution which we are going to discuss, first I'm going to discuss at length the two-step method where you can graph this trigonometric function without any calculation of transform points. Important, right? And you can do it in just few minutes. That is the greatest part of it. But however, many times it is specified in the test paper that you need to write down the points. And for that, I'll take in the second half of this video, how do we write down the points? Perfect. So it makes sense, right? So now let's first begin with our two-step method solution. So first we'll consider the basic concepts, and once we have the concepts in hand, we'll sketch the graph. I'll discuss with you some couple of strategies which can help you. Correct. So first step is that we are looking into cosecant. So whenever you have cosecant, that means in your mind, sine function should be there, right? So you know what is cosecant, right? So cosecant theta is equals to 1 over sine theta. So basically, we need to sketch the sine graph. And once we sketch the sine graph, then we from there we can draw the vertical asymptotes, right? Flip and get the cosecant graph. Perfect. So that is the strategy. Now, even before going there, we need to rewrite our function, which in this case should be minus 4 over 3 cosecant. Now, I use square brackets to factor out half, right? So it is half of what comes in the bracket? X plus. Since you factor out half, it should be 4 pi by 3, correct? And here we have plus 7 over 3, correct? So once you have this, you have a couple of things in your uh, mind, and that is one of the most important thing is we have to now sketch, let's say g of x, which will basically be sine function, right? Will be sine of half x plus 4 pi by 3, right? Plus 7 over 3. So that is what you have to sketch. Once you sketch sine function, then it is easy to sketch cosecant function, right? So that's what we are going to do. Great. So remember one thing, when you have this, what is the period? So time period t will be equals to 2 pi divided by half, right? So that means the time period is 4 pi for this particular case. And what is the amplitude? So amplitude basically is equal to 4 over 3. It's always the positive value. And here axis is how much? Axis for the sine graph is y equals to 7 over 3, right? And we have a phase shift. So this is the phase shift value. We'll write p here, lowercase p, as minus 4 pi by 3. So that means it moves left by 4 pi by 3. Now, as you can see, in this particular case, most of the values involved, 4 by 3 is like 1/3, 4 pi by 3 means 1/3. So that helps you to decide on what kind of scale should you be using, right? So let me just use a scale here. I'm not drawing the graph, but I'm just showing you the scale. The minimum division which you should have should be one third, right? And over here, it should be at least pi by 3, if not pi by 6. So it could be pi by 6 also. So pi by 3 I've written here. So 4 pi by 3 means 4 of these, 1, 2, 3, 4, will give you one full cycle without a phase shift, right? And because the 4 pi, phase shift is 4 pi by 3. So that much it will move to the left. So you need a big area to work with, right? So I hope you're getting the point. So once you have pi by 3 as your unit square defined, you can shift left and right by 4 pi by 3, correct? Making sense. Now, also note that there is a reflection on the axis. So the sine graph basically will be kind of going downwards, right? So let me give you a rough sketch of the sine graph. How should it look like? So we'll have an axis which is y equals to 7 by 3. It has been translated so many units down, right? And period for the sine graph will be 4 pi. However, it has to start from minus 4 pi by 3, right? So this point from where it starts is minus 4 pi by 3. You get the whole idea, right? Minus 4 pi by 3. And it is going to end after one full cycle at this point, and that should be equal to how much? You have to add 4 pi to this, correct? So minus 4 pi by 3 plus 4 pi. So 4 times 3 is 12, right? And 12 minus 4 will give us 8 pi by 3, right? Let me rewrite it. 4 pi plus 12 pi, right? Over 3, which gives you 8 pi by 3. So this point here is 8 pi by 3, correct? What is the maximum and what is the minimum values? Well, for the maximum value, you have to add 4 by 3 to 7 by 3, right? So this will be 7 by 3, right? Plus 4 by 3, correct? Which is 11 by 3, correct? So that is the maximum, and minimum will be 7 by 3 minus 4 by 3, which is 3 by 3 or equal to 1. You get the whole idea, correct? So you get the maximum and the minimum points and your graph as shown here. So that becomes a sine function, right? To sketch the cosecant function, what should you be doing? Well, you will actually draw the asymptotes at these points. Wherever the sine graph is intersecting the axis, right? And then flip it over means your graph will be kind of like this. You see that? So that highlighted graph is what represents cosecant graph. So that is the base of our sketching the graph for cosecant function. I hope you have understood these steps. Perfect. So once again, let us now sketch it on the graph paper, right? So here we have a graph paper. As you can see, what we did was we wrote this function as minus 4 by 3 cosecant. We factor out half, correct? We have x plus 4 pi by 3 and plus 7 by 3, right? So first step is 7 thirds. So every division is 1 third, right? So this is like 1, right? This is 2, correct? This is 3, right? So this is 1, 2, 3, correct? You understand? And each division is divided into thirds. So where is going to be our axis? our axis will be at 7 thirds, right? So 1, 2, 3, 4, 5, 6, and 1, 7. So that becomes the axis. So this is y equals to 7 over 3 on the graph paper, right? Easy? Correct. Amplitude is 4 by 3, 4 thirds, right? So what I will do here is draw a dotted line for 4 thirds, right? So 1, 2, 3, 4, right? So that is the 4 thirds, correct? So maximum is this, right? Which is y equals to 7 by 3 plus 4 by 3. I'm not writing 11 by, or let me write 11 by 3. Is that clear? Similarly, the minimum will be 4 thirds below this, right? 1, 2, 3, 4 at 1. You see how easy it is? We are not really calculating the values. Okay, so this is y equals to 7 by 3 minus 4 by 3, which is equal to 1. Is that clear to you? So we know maximum minimum. Now let's point out the period. Period for us is because cos cosecant half means sine half means period of not 2 pi but 4 pi. So 4 pi and every division here is pi by 3, right? So 1 pi, 2 pi, 3 pi, 4 pi, correct? So that becomes 4 pi, right? So let me just mark it on the axis, these 4 divisions, right? Correct. Now we are also looking for negative, right? Means the sine graph will start from the axis, but it will go downwards. So sine graph will be kind of like this, going downwards, right? So it goes from the axis, so axis to the minimum, sorry, here, then back to the axis, and then to the maximum, and then back to the axis. We are only sketching one wave, okay? So this graph, which I am drawing here, is basically sine function without the phase shift. Is that clear? So what I have drawn here is minus 4 by 3. So let me write down here what I have drawn in blue is, so let me call this as h of x equals to minus 4 by 3 sine of half x plus 7 by 3. Makes sense, right? We have not done the phase shift. Now we are going to do the phase shift of 4 pi by 3, right? So to this, we'll do the phase shift of 4 pi by 3 means moving each critical point 4 pi by 3 left. So 4 divisions, correct? So it is like 1, 2, 3, 4, correct? So that is the position minus 4 pi by 3. So each will come to this point, right? And here 1, 2, 3, 4, correct? This 1, 2, 3, 4. Make sense? From here 1, 2, 3, 4. Correct? From here 1, 2, 3, 4. I'm only drawing one wave, right? So that becomes our final graph, which will be for sine, correct? So that is the function which is, let's call this as g of x, which is minus 4 by 3 sine half x, and within bracket, or let me write x within brackets, shifted 4 pi by 3 to the left plus 7 by 3. Do you see the sine function now? Correct? Of course, this is periodic, so it will move. Right. The idea is to sketch the cosecant function. So cosecant function will have a vertical asymptotes right there. So I am not drawing the vertical asymptotes. wherever the sine graph is cutting across the axis. Perfect. So for only one wave I am drawing, you can extend this since the function is periodic, right? And now we can extend this and draw the cosecant graph as this. You get the idea, right? Perfect. So, so that is how cosecant graph will be sketched. Does make sense to you? Perfect. So we got a result. So what I've done here is shown you exactly without even doing the calculations how do we draw it. You can of course do the transformations, get all the points and also sketch it. However, this is a beautiful technique. We got all the points on the graph, right? Minus 4 pi by 3 and then from 4 pi take away 4 pi by 3, right? And so we have that point here as 8 pi by 3, right? So from minus 4 pi by 3 to 8 pi by 3 gives you one period of the sine and also cosecant, right? So for your reference, here is the actual graph which it should look like. So once again, let me just tell you that the graph in orange shown here is the graph of sine function, which is minus 4 by 3 sine of half x plus 7 by 3. So this is without phase shift. Perfect. So without phase shift, this orange line is easy because we inverted it, correct? And took our 5 critical points and sketched the graph. Then the second graph which we have drawn is basically this one right here. And this graph is with the phase shift, right? So this is minus 4 by 3 sine of half x plus 4 pi by 3 plus 7 by 3. Makes sense? So we got the blue graph which is shifting towards the left. You see that? By 4 pi by 3. So this point here is minus 4 pi by 3, correct? So we get our sine function. Now to get the cosecant function, we first drew wherever you have this, your vertical asymptotes, correct? You see that? So wherever the blue graph cuts the axis, we have the vertical asymptotes. Neat. And then we flipped with a common point the sine graph to get the cosecant. So that was the way which we had drawn, and it can be extended, perfect, as shown here. Does it make sense to you? The whole graph has been drawn accurately without even calculating the transform points. However, you can always use the transformation to get the points, right? We are back with you. Two-step method, simple and useful. Now let us see how do we sketch this function using the points, right? So we already have a graph. These points help us to verify that the graph is absolutely correct, right? Okay, great. So once again, for the function, we'll write this we'll factor out the argument. So we can write this function f of x as equals to minus 4 over 3 cosecant, factor out half, and I use square brackets for that. So we get x plus 4 pi by 3, which clearly indicates that the phase shift is 4 pi by 3 towards left. Correct. So we did all the calculations earlier, understanding the transformations. Now, you know, to do this, we should be working on the sine function as we did earlier. So it is sine function which we are going to sketch. Perfect. Now, in sine function, as you know, basically, sine function looks like what? Sine function starts with the axis, right? Goes up to 1, comes down to -1, and then back to 0. Great. So, the five critical points which you have to always consider are these five, correct? So, we call them xy. So, let's call this xy points. Now, after transformation, what happens to these? This is what we're looking for, correct? So, the five key points for us are 0, 0, right? And then this is at pi by 2, 1, and this is at pi, right? Let me write this 0, pi, 2 pi, correct? So we have pi again 0, and then we have 3 pi by 2 minus 1 and 2 pi back to 0. Correct. So you got these points. Now, after getting these points, we need to understand the transformation. The horizontal value gets modified because of these two parameters. So let me include them. So it becomes 2 times the x value minus 4 pi by 3, correct? That is phase shift left. And as far as the y values are concerned, we need to multiply by minus, right? So we get minus 4 over 3, right? The y value and add 1 over 3. Correct. So that is how you're going to do it. Perfect. So you can do your calculations and get the corresponding values. Is that clear to you, right? For example, when you put 0 here, it becomes minus 4 pi by 3. And 0 here, it becomes 1 over 3, correct? Right. So basically, the axis moves to 1 over 3, right? So that means you have to have a scale where each unit is 1/3, right? And then you sketch it. So for you, we have done the calculations. Here is the table of values. So as you can see, the five critical points has been taken for sin x, which are 0, 0, pi by 2, 1, pi 0, 3 pi by 2, minus 1, 2 pi 0. Correct. After applying this transformation to the function, these are the calculated values. So the graph actually begins with minus 4 pi by 3, which is to the left, and at that time the value is 7 over 3. Right, so 7 over 3 is the axis now for the graph. The next value is minus pi by 3 with 1, 2 pi by 3, 7 over 3, and then we have 5 pi by 3, 11 over 3, and this is again back to the axis. So once you have these points, the graph we already drawn and shown you earlier is right there. So you get your blue graph, which is right there, right? So these are the points which we just worked out, correct? So that gives you one sine wave. You can always repeat it. And then once you have the sine wave, then the cosecant is reciprocal. So for the cosecant function, at these points, you have to draw the vertical asymptotes where it is crossing the axis. Once you extend the graph, you get the other points also, right? So I've shown you one wave only, but you can always extend it at least to two, right? So once you have this, then as you can see, flip it to get the cosecant function, which is this, right? So that is how we could actually get the same result which we got last time with my two-step method. However, in this method, we have to do all the calculations which I have shown you, and in two-step method, you don't have to do those calculations. That is one big advantage. However, both methods are followed. Select the one which you like most and explore our playlist to learn. Thanks for your valuable time and all the best.